Three, two, one, live. Hello, we're happy to see you, or virtually see you, on our third session. This time it will be a talk by Milen Dyankov. He will be presenting topics like event sourcing, DDD and CQRS concepts. That's short introduction, and now I'm passing my word to him. Hello, Milen.
Hello, thank you. I'm very happy to be here. Thank you for having me. And let me switch to my slides. I hope this is what you see now, because I have some issues with my monitors. Turns out I don't have enough of them to be able to see both the slides and the conference room, but let's see, we'll manage that. So welcome everyone. Super excited to be able to give the talk today, and appreciate you watching it on Saturday. That's not unusual thing. It's actually interesting thing. I guess it's a nice way to make conference more entertaining. There's always a chance to see someone's kids running around or someone's dog barking in the background or things like that. I hope none of this is going to happen to me, but just to let you know it's possible. So today we'll be talking about memories, and memories, that there's a reason why that is plural, because it's not about the memory of your computer. It's not the JVM memory. It's not those things that you as a software developer typically think of when the word memory appears. It's memories like we know them as humans. It's like the things that we remember from the past. And whether or not having applications remember things that has happened in the past makes sense. So to just put us all in the proper mood, let's start with a little movie reference. I don't know if you're familiar, if you know that movie, Memento. It's a production from 2010, I believe, or somewhere there, directed by Christopher Nolan. And it's a very interesting movie in a sense that it touches the idea of lack of memory. So the line goes, there's a murder investigation, and the guy the main character tries to prove or actually figure out who is responsible for that. And there's only one caveat in that whole thing. He suffers from a severe condition. He is unable to form new memories. So he has memory, like working memory. So he remembers things for as long as he deal with them on a regular, at the moment, but he forgets them kind of shortly after that. So it's very interesting to see how you deal with a situation where your long-term memory is affected. Right. So he reaches out to methods like obviously writing things down, like he has notes all over the place, but those can be altered, right? Someone can change them or destroy them or whatnot. So for example, he uses techniques like tattooing information on his body and stuff like that. And it makes you think like that simple thing like memories is something I would never pay attention to. We just always have it for granted, right? And we use it all the time. We don't realize we use it, but it's a fundamental thing. And now if you're going to say like, okay, come on, that's just a movie, like anyone can come up with like a crazy story like this. Well, that's not entirely just a movie. And as a matter of fact, as rare as they are, such things appear in real life. Like one such example is this person, Henry Molaison, who suffered from epilepsy and had a surgery, I think back in the 50s, if I'm not mistaken. And as a result of that surgery, a damage was down to his brain, and he got exactly that condition. He became unable to form memories. So it's not something that will never, ever happen to anyone. But that's not to scare you, just to think about, and it's like, we as humans obviously immediately start thinking like how we would feel about that. But I don't want you to focus on how you feel about that. I want you to focus on what that would mean in terms of the things that you do, and in terms of the quality of your life, the quality of your decision-making process, everything that you deal with on a day-to-day basis. right? Just to give you an example of what I mean is before all this lockdown, I used to spend a lot of time on those, traveling for conferences, visiting customers, doing trainings, all kinds of things. And one thing I realized at some point in time, I was doing a lot of booking, flight bookings and flight seat picking. And one thing I realized is that my memories about previous trip started to heavily influence the decisions I make about which seat I pick. Right? The process of booking a seat, picking a seat in a plane, it's straightforward. Like you get a map, you pick a seat. You can just do it randomly, right? But with time, you don't do it this way. You start thinking about like, okay, would I prefer a window seat over an alley seat, or vice versa? Should I avoid the middle seat? Like where are for example, in this airline, the last few rows don't have storage space because there's the compartments are used for some kind of equipment and stuff. Those things, they are memories. They're knowledge that comes to you from your memories, from the things that had happened to you in the past. And you didn't store them as a state in your mind. You just recall and get them every time you need them. And so why it is not impossible to book a plane seat without a memory of previous flights, it's certainly having those memory can enhance the decision-making process in a variety of ways. And we humans do that all the time, kind of naturally. But that's not the same for software systems. So software systems typically don't have memory. So they don't the creators of the software systems don't think of having a memory as something that is of a value most of the time, or even worse, they oftentimes would even not consider it being a significant limitation or constraint. If anything, it would be kind of an overload, a needless effort or something like that. Think about a product catalog system or a shopping cart. It's like, okay, you have the shopping cart and it only needs to know the state, right? What products are in the cart right now, right? So that's what it shows you. And then when you go to the checkout process, that's the only thing that happens there is that you need there. It's the state of the shopping cart, so you can do the final math and whatnot. And like what has happened in the past, like all the interactions, adding books, adding products to the cart, removing them from the cart, that's kind of irrelevant, and that's it's often seen as a needless or like just adding more mass to the whole thing, right? So we most of the time design systems that don't have memories, purposely don't have memories, because we don't see a value of doing the extra work to get that to our systems. Except that's not the case. We actually do have memory. Like most systems do have memories, and we call them logs, right? And I bet you're gonna have a hard time finding a production system that does not have logs, right? It's like they may be very verbose, very detailed. They may note every single thing that has happened, or they can be just occasionally noting things down. But most systems do have logs, and they store them in some place, but they never use them, right? And if you think about it, like imagine that you have your memories, but you can't use them, right? They exist for the sole purpose of someone else examining your behavior. That would be pretty disturbing, I would guess, right? But that's exactly what we do with software systems. We give them logs and we ask them to keep track of all these things just so that we can examine it, and don't give them the ability to actually make any sense of that. Well, okay, that's not entirely true. So there is this software systems called databases. And those are the last one you probably would suspect of making good use of memories, but in fact they do. They have these things called transaction logs. And the transaction log is, as a matter of fact, one of the important features when there's a database migration, for example, or where there is a process of restoring data. So essentially, the transaction log is the place where every single thing that has happened, like you added, you remove the thing, you restructure, you alter the table or something, that results in an entry in a transaction log. Now, obviously, I'm oversimplifying things here because that varies between different databases, but that's the basic idea. So everything that results in a state change is being tracked in this transaction log. Right, then you can replay that log at some other instance or after a crash and restore the state of the system just by applying all the events one by one. And if you think about what this does, that's not different from what we call event sourcing these days. That's exactly what event sourcing is. It's reconstructing the state based on previous events rather than storing the state as of any given point of time. So now that we know that logs are good, memories are good, and they can be useful, the natural question is like, okay, so can we do that like all the time? Like do we need to actually store state at all if we can get to the state by replaying or just monitoring the event flow, all right? So maybe we can. Now, if you think in terms of databases about that, that's probably the answer that comes to you immediately. It's like, that's nonsense. And that's almost, that's true. And the reason it's true is because databases are a very generic piece of software. Their purpose is to store data, all kinds of data, and get that data back to you in a form that you request, right? They don't really care about what the data is about. Like, the database itself has no knowledge of the meaning of the data. It's you, once you get the data, that decides what exactly does it mean, that value in that column in that table. But for us, for the database itself, that's irrelevant knowledge. So it's so generic. It's just basically concerned with efficiently storing and retrieving data, that applying this process on every request would be an overkill. But that's not how our applications work. That's not how most business applications work. Most business applications work in a way that they're constrained. They operate in a specific domain, right? They operate on a specific domain knowledge, and they need to make decisions based on that knowledge. They need to know, they need to understand the meaning of the data to make those decisions, right? And oftentimes, to make the decision, they just need a very small amount of data to make that decision, right? So if this still sounds ridiculous to you, let's do a simple exercise. How much money do you have in your pocket right now, or in your bank account, or in your credit card statements, or whatever is the thing that you use? Like, think about that for a second. The chances are you don't have the exact amount stored in memory. So those are the things that you don't, the state of that is not something that you store in your memory and constantly update. But when asked this question, most of you would be able to go back in time and say, okay, at this point in time, I had X amount of money, and then I spent X amount of money on this, and then gained some money from there. And just by applying the events that caused either you losing money or gaining money, you can restore. Well, we humans, so we always work in some boundaries of approximity, but we can relatively with relatively good precision restore the amount of money that you have at your pocket or wallet or bank account. Right, and that's exactly like what I'm talking about. That's exactly how event sourcing. Sorry, there's too many things about events these days. That's exactly how event sourcing works. It's just applying the past events until we get the state that we need, right? And one thing to notice in this example is, like, take into account the time frame that in which you restored that. It could be days, it could be hours, it could be weeks. But in any case, in that time frame, when these events of you either spending or gaining money, those events occurred to you, there were millions, or if not millions, probably thousands or hundreds of other events that occurred at this time period, right? That you went somewhere, you did something, someone told you something. It's like millions of events could be happening in between. But when you face the question about the money, what came up to you immediately was only those events that were relevant to that very specific question, to that very specific decision that you're about to make, right? And that's exactly how we approach things in applications. Like, we don't have to have the whole state in order to make a decision. We need to get the information that's relevant for the domain-driven, or the domain-specific decision, and then just operate on those. And this is exactly the concept of aggregate from domain-driven design. So aggregate is basically aggregating all the information that, from business domain perspective, can be seen as a whole, right? And can change as a whole, or can cause us to make a decision as a whole, right? And we just get that information that's relevant to that particular decision that we make, and we ignore everything else, right? And when I explain this to people, oftentimes what I hear is like, well, no, I'm thinking about my system, and there's plenty of cases where I need to know the entire state of the system, right? I just can't make, I can't tell, like, getting the specifics of an aggregate is just not enough. If that's the case, you're most likely thinking about QRS. So yeah, there are cases where you need to know the state of the system. But when you need to know the state of the system, it's kind of like the question, how do you feel, right? You can't answer how do you feel by event sourcing from the past, and it's also a context related, right? So how do you feel is actually a projection of the things that had happened to you in a given context, right? How do you feel at work? How do you feel at home? How do you feel in the morning? How do you feel in terms of health? How do you feel in terms of satisfaction? There's millions of ways to look into that, and they're all projections of the same things that has happened to you in a different context, right? And that's what that's something that in software development we help separate those actionable things by those asking about the state of the whole things. The pattern is called CQRS, Command Query Responsibility Segregation. And so commands are the things that asks for action. And typically, like most of the time, when you deal with a command, it goes to an aggregate. It goes to a very limited set of data, and you make a decision based on that very limited set of data, right? You think about how that works in real life. Like, every time you had to make a decision, you didn't consider your entire life and everything that has happened to you since you were born, right? Because it's impossible to make a decision taking into account everything. Every time you make a decision and you perform an action, the decision you make is based on the events relevant to that particular decision that you're about to make, right? And oftentimes on the other side, when you get like the kind of how you feel questions, like you kind of get an overview of like all and everything that has happened to you, right? And so you keep a projection of that in your mind somewhere, right? That represents the state of the thing from certain perspective. So those are the things between the differences between queries and commands. And now that I've taken 20 minutes of your time telling you like the background of this, you're probably tired of me talking, so you want to see some code. And this is what I'm going to do with a super simple demo, which will demonstrate the things that I was telling you until now. So what I have here is an application that is simulating buying books. So I'm just going to walk you through one method here, which is called simulate client shopping. And I'll skip that section for a while, and we go here. So basically, we're going to create a cart, and then we're going to have this create shopping cart command. So let me show you what the command is about. It's basically a class with some fields. And we also have a checkout command, an add book command, and a remove book command. So to represent the actionable things that we want to do. Right, so we create a shopping cart command, and then we use this thing called command gateway, which I'm going to explain in a second to you, to send this command, right? And then for random number of books, we're going to send an add book command, which basically simulates adding books to the cart. Then we're going to use some weird, crazy conditions here to eventually remove a book from a cart, just so to see to demonstrate the action of like, oh, I changed my mind, I don't want that book anymore. And if at the end of the day, when we're done, we're going to send the checkout command, right? So let's start this. Here we go. And I have a small shell here, so I can interact with this thing. And let me issue this by books command, which is going to call the method that I showed you earlier. And oh, you'll see a nice surprise. It says there's no handler for the command. Well, the reason is that thing that I showed you here, the command gateway, it sends commands somewhere and expects someone to deal with it, to handle it, but there is no one. Where does it send it? It sends it, in this particular case, to what I would call the brain of the whole thing, Upsell Server. It's an application that runs on my machine right now. It can be run in the cloud. And it's a combination between event store and a message bus, so to say. And so you can look into here and see where is my overview, that I have my Upsell Server, and I have one application, my client application connected to it. So it sends a command and says, do something. And this guy says, well, I'd love to, but there's no one who can do this for you. So let's give it someone that can do this for you. So I have another application here. This is the one that I show so far is my demo client. And I have this shopping service here. And shopping service here has this shopping service cart. And as you can see, that's a basic Java class, which is an aggregate. It aggregates all the information about a shopping cart, right? And it handles commands, right? So the one command that it can handle is create shopping cart command. And when it does, it creates a new instance of the cart. And then it uses this aggregate lifecycle to send an event. And the event it sends is shopping cart created event. Now, so that's the important part here is, like, we got the command and we were doing something with it. And then once we're done, so that we're doing something with it means like we decide whether or not we should actually perform that action at all. We decide like maybe we should do other things before or set some things. Like that's the decision-making process right here. Like you got the command and you have to decide whether you do it, if you do it, how you're going to do it and whatnot. But once it's done, it's done, right? That's it. We don't go back in time. We don't change our mind. So we issue an event and basically say, okay, shopping cart was created, right? And we send that event through the lifecycle, right? And so the same thing goes with the command handler for add book and remove book and whatnot, right? So, but then if every time we want to get to the state, how do we do it? So we do it by not only supporting command handlers, but also event sourcing handlers. And so you see here that we now have a shopping cart created event. So every time we want to restore a state of the aggregate from the past events, those will be called. And then we update the state of our aggregate. So we're going to get the car ID and the person ID on the book added event. We're going to add books to the state and whatnot. And we'll be relying on someone telling us what happened when those events happen, and then how to restore the state. You'll see in a second. So for now, I'm just going to go ahead and run this. Okay, and there's going to be another console here. Okay, so this application is now running. And if I now go back to my dashboard, you see now I have two applications. I have the client and the shopping services application, right? And if I now go and do the same thing here for the from the client, say buy books, you see now the process went smoothly. So this person, Kaden, logged in and bought the book, well, added the book to the shopping cart, then decided he doesn't want it, or she, not sure if that's a male or female name, then added another book, and eventually checked out. Now look at what happens on the shopping cart application. So the shopping cart application, something started happening, and we created a new shopping cart. Well, it created it, okay? And then it handled the create shopping cart command, right? And then it sent the shopping cart created event, and then it got back the event and it's updated its state. So it's not updating it from the command, it's updating it from the fact that something has happened in the past. Then something else happened, and we got the same thing again. We created a new shopping cart instance, and we got this previous event again here. So we set the user, and then now the state of our shopping cart is already recreated from the past event, and so we can now handle add book command, and then we send them an event that the book was added, and then we update the state of the shopping cart again. So when the book was removed, we recreate the state by starting with clean object, adding, like setting the user, setting the book, and then we execute the book removed event, and so forth and so forth. I'll show you just the last one. So here, that's the checkout process. So before we actually reach the point where we handle the checkout, we get all these events that have happened in the past. So the user, the card was created, user was assigned to the card, book was added, book was removed, book was added, blah, 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 and finally handle the checkout event, and then we send the checkout event, handle the checkout command, and then send the checkout event. So the next time we want to, anyone asks to recreate that shopping cart, we already know it's being checked out, right? So, and then that is not only in that's not state that holds in any application or database. It's actually hold in this thing, which I call the kind of the main brain of the whole thing, the Action server. So if you look into here, you can see the commands that have been issued, how many times, and who handled them. So all these commands were handled by Shopping Services app. You can also see queries, and there is a query book purchased, but it wasn't handled by anyone. That query is actually what I was telling you about projections. So here it is. It's essentially another class which has event handlers. And storage. Now, my storage for this is super simple. It's a hash map, but you can imagine this could be a database or anything that you want to use to store a projection of the world. And that projection of the shopping cart for me is like how many books were purchased. So it basically listens for checkout event and updates this state of the world. So when that is the wrong window, so I'm gonna have to run this again and need to go to Java process. Here, that's the window. So when I say what is the sold copies? Okay, I need to be more consistent with naming things. So if I call this projection by typing sold copies here, I need to provide it a book. Let's say this one. It tells me there are no copies of that book sold. But if I say the tail of something, Yeah, it tells me that one copy of the book was sold, and that is because my projection keeps getting this event and builds my query my query goes to the projection that keeps the representation of the world of the shopping cart in terms of how many books were bought. And if we go back here now, you see that the book purchase event, query was issued 2 times and handled by shopping services application. Right. It can also see the whole events. So all these events that we issued in the past, they are now stored in this event store, and it knows the events, it knows the queries, and know the commands. But as far as the events are concerned, it also knows who is connected. And when something is asked, it will actually send that information to that particular handler so they can rebuild their state from the past event. Okay, that's all nice and good for a demo, and you're like, okay, you gotta be kidding me, like showing me some stupid shopping cart thing that's super easy. Yeah, I agree with you. So now imagine that you're not in this state, but you are actually, and I'm just gonna go to my Docker and stop this Axon server and start another one. I think it's this one. Okay, so it's gonna take a second to start. And now, come on. Okay, so let's go to NC-cert and see this one. I see there's no event. That's because it only shows you the last hours. But if I say custom and I say search, you see there's tons of events loading. And I'm just going to say group by, so to show you how many events are here in this server already. I think it's overall like over 5 million events or something. So it's still not a mind-blowing number. It's like not a billions or something, but it's a fair amount of events for a relatively small app, right? So that's 3 millions of book added, 1 million shopping carts created, and whatnot. So it's an application that was live for a while. It's being used and it has a state, right? So it's not something that we just designed. And at this point in time, a business comes to you and says, okay, you know what? We have a new business case. We want to be able to give promotion or discounts to all the people who have who wanted to add a book, to purchase a book, but resign. Right. So if you have someone who added the book to the cart and then remove it, then we want to give them now discount so they can buy that book. Right. Now, if you have a traditional state stored application where you only know what was the shopping cart at the time of the purchase was done, you can't do this. Your only answer to this is like, oh, I'm sorry, we didn't know you're going to need that. So now we can add this feature for the in the future, but we can't possibly tell you about anything about those 5 million things that happened in the past, right? But when you have the application memories, when you have the things that have happened in the past, you actually can do it. And to do that, I'm going to show you by adding the third module here, this Upsell Service. And the Upsell Service app is essentially only has one thing, a projection called books considered before. And so that's, again, just a hash map, but obviously you can use it in anything else, like a database or something. All right. And it reacts on shopping cart created, book removed events, and checkout events, and calculates every time an event occurs, calculates how many events, which books were added and then removed and never purchased. Let me start that. Okay, and when I started, what you will see here is that immediately starts processing the past events, right? So it's going to take it a little bit of time to build up the state, right? And considering it has to go through like not all of them, but like 3 million events or something, all right? In the meantime, when we go to the overview, you can now see the Upsell service was connected, and it's processing these events. One thing that I skipped in the beginning and in our client is this here. So we have this attempt here to, when a purchase is made, to send the book considered before query. And if we get a result about the books that were considered before but never bought, we apply the discount. So as you saw in our previous process here, which was here, we didn't apply any discounts. But now that we have this application processing the past events and actually knowing this, if I now say buy books, what you will see is that this person got the 10% discount on 2 books that he tried to buy before, but gave up for whatever reason. And now we know that this could have happened yesterday, 2 months ago, a year ago. It doesn't matter because we know the history and we can make a decision now about enhancing the book purchasing process based on something that has happened in the past. Obviously, I don't. I just do it super simple here, so I just check if it exists. In a real-world scenario, you probably want to be doing it in some time frame or with some extra conditions and whatnot. That's of course obviously that's doable. But the point is, you now have access to the memories, and you can enhance your decision-making process based on those memories, not only add new logic that only going to apply for the future things. Okay, so in that real short movie demo that I showed you, I just wanted to point out the actors so that you know what I was using. So the event store and the message platform, these roles were played by this thing called Accent Server. I just happened to be the thing that the company I work for provides. It's an open source technology that you can use, can download and use, or run it in Docker container, or it's an executable jar file if you don't want to play with Docker. Up to you. Now, as you saw, all the classes and stuff, they were plain Java objects. And this concept of like aggregates and command handlers and query handlers and isolation of things, those are provided to you by a thing called Accent Framework. It's essentially like a very low overhead framework that makes all those things super easy to work with. You don't have to, you can use something like Kafka, for example, and then your own code to simulate this, to build the same thing. It's perfectly doable. I'm not saying that like this is the only solution to that problem. If you just want to give your application memories, there's other ways to do it, but those are dedicated for event sourcing, DDD, and CQRS, and just make your life super easy. And if you want to apply those concerns. On the right, you see the links to get more information. And there are a few other things that you didn't see or I didn't explicitly point you out to. But they are, it's worth noting that they are there behind the scenes, like message correlation, interceptors, exception handling, sagas, and many other things, as well as integrations with pretty much all popular technologies are there, like Spring Boot, and Kotlin. There's a Kafka connector and tons of other things that potentially you may want to use. So the thing is, we want to bring this to you to enhance your applications. We don't want to tell you like, okay, whatever you're doing, throw it away and start using our stuff. We want you to feel right at home with the tools that you already use, but then enhance your applications so then they can have memories, and then you can make better decisions based on that memories. I'm not sure if that short demo was convincing enough that that's a good idea. If not, you can always reach out to. But if it like exceeded the plan, you can always reach out to us, whether to Axonic or whether to me directly. I'm always open to discuss those things on any of the social platforms that you can find me. And that is for today. I'd love to thank you for spending this Saturday with me and this talk. And I wish you great success with all the projects, upcoming projects that you will be working on. Thank you.
Thank you, Milen, for your great talk. Thank you for joining our conference as well. Let me check if there are any questions. Unfortunately, we don't have any questions.
Yeah, that's sad.
Yeah.
That's okay. Maybe you have some.
No, actually, I don't work in this like domain, so I don't have anything smart to question. And we don't have books to gift for questions for this.
Yeah,
Probably
that's my bad.
No, well, we have a special partner for that. That's not your fault.
Okay.
Okay, then I'll go.
Okay, for if there's some people still watching and thinking about the question, asking questions, I'll be hanging around on the platform for a while. So mention me, find me. I don't know how that works on that particular platform, but I'll be happy to answer those questions if they pop up in a few minutes or so.
Yeah, I want to add that you can find a speaker or just any other person in this platform and DM it, direct message. So just write in a Pine tool. And probably Milen will be in a special chat. I don't know. You can find him there too, if he is. Thank you, and see you on the next talk.
Thank you. Bye.
Bye.